with them momentarily. Good evening, everyone. We are pleased to welcome our faculty for today, Mr. Felix Emeka Anyiam, a seasoned research data expert, data scientist, and biostatistician. He is also a member of the editorial board at PLOS1, bringing a wealth of experience in scientific research, data analytics, and publication standards. Without further ado, Mr. Anyiam will now begin his session.
Yeah, hi everyone. I hope you can hear me clearly. I hope everyone can hear me.
Can.
Okay, all right. I got a message from Taiwo. They can hear me. All right, thank you. So I'm happy to be here, and I also, before I start, I would like to appreciate the Fire Right organizers, Dr. Kudirat and the husband, and also Professor Mojid. So thank you so much for the opportunity to actually hold this session. So like is displayed on the screen, we'll be looking at data collection and measurement. And I added something on sample size because the last session we had, somebody was asking about sample size determination. So I said I was going to add it to this slide, so that I would be able to answer that question adequately. Thank you. So you're welcome, because today's topic will simply be talking about data collection and measurement, and with sample size determination. We will explore fundamental research methodology elements, and we would also have some expert navigation through research principles in this process that I would like to discuss. So we would understand fundamentals, grasp core principles of data collection and measurement. We recognize various types and tools for measurement. We'll assess validity and reliability in the measurement. And we would also use methods for determining appropriate sample size. So what is data collection? Now, from the definition here, it says systematic process of gathering information on targeted variables. That is what it is. Now, that word systematic tells you it's not something you do haphazardly. It's not something you do anyhow. Systematic simply means there's a pattern, there's a process, more like an SOP, a standard operating procedure in how these things are done. Okay, and it's not something you just do haphazardly. And it will interest you to know that for you to even go into the process of collecting data, you first of all would have started your research process. In other words, you probably have something you want to solve, like we discussed the last session, a problem you want to solve. Now, based on that problem you want to solve, you are able to craft out some research questions, some hypotheses, in order to help you evaluate the outcomes or the disease condition or whatever the research problem that you want to solve. So these processes is what now gives birth to what type of data am I going to be collecting. Now, based on the data that you're going to be collecting, it will now motivate you on the type of data collection tool that you're going to be designing, and some of the examples of these data collection tools, may be a hospital exit survey, meaning some of those surveys you see in hospital that are kept on the decks as patients are leaving the hospital, they fill them so that the hospital will be able to know how the patients were served, if they were satisfied or not, or their satisfaction. Yeah, like I said, using different types of variables which we would look at as we proceed. So how do you collect this data? It depends on what you want to do. There are some research questions that are okay. You can use surveys and questionnaires, especially when you're doing studies that are prevalent studies, incident studies, those national surveys, those type of studies where you'll be measuring prevalence, incidence, quantitative variables, variables that have sizes, surveys, also called questionnaires, are, better for those kind of uh, research. All right, but there are some that you may not be looking at quantity, you may not be looking at size, you would be looking at things you can measure, like things that has to do with strategies. You can measure strategies. You can't really tell the size or the level or the quantity. So in those kind of assessments, you will need to do some qualitative, where you'll be doing interviews and focus group discussion. Now there are some studies where you would not have an interaction with the participants. They are usually called observational kind of study. Like there's one I did, which I often use as an example, the study on the noise-induced hearing loss. I had an observation part in it where I went to different churches that use loudspeakers. So I was able to measure the sound pressure levels in those churches without having interaction with anybody. All I need to do is just sit down in the congregation during service, and I bring out my sound pressure level, and I was able to check what is the sound pressure level is during the word, during praise and worship, during the announcement. Sometimes the sound pressure level will fluctuate between 40, 60, 85 decibels, So those are observation. And those of us that are in in um, in especially these occupational health, those of us that are in occupational health will be used to observational research. Yeah, sorry about that. So we're having the observation, like for sorry, could you go? Yeah. So like I said, for those of us that are in occupational health, where you have to measure those that are using, personal protective devices. You go to like a rig, you go to like a company. Apart from the fact that you have alerted the company that you are doing some studies, the day that you come to do the observation, you're not supposed to alert them, because if you're going to be measuring how many of them are wearing their safety, headgear, how many of them are wearing their safety boots, how many of them are wearing, their safety Google. If you let them know, everybody will kit very well, and they will look as if they are 100% compliant to safety. So in this kind of instance, you don't tell them. All right, you just go in and observe. That's why it's called an observational study. You don't tell anyone, you don't talk to anyone. Are they wearing their headgear? Check. Are they wearing their helmet? Check. Are they wearing their Google Glass? Check. Then you'll be able to see the compliance of that, company. So the other one is the experiments or the trials, especially when you're testing a new drug. You'll be able to design tools that will have the two groups that you are testing, either is the intervention group or the control group, more like a comparative study kind of tool. You'll be able to now assess for the intervention group and the control group what is the level of recovery based on the intervention that is given to each of the group. So these are different data collection tools, especially for those that are into survey. There are many of them. There may be much more than these, but these are the ones that are really, really popular. I have used Quadrix before. It's an online tool, where you take data real time. Redcap is the same thing. SurveyMonkey, Google Form. So these are different data collection tools that can help you collect data at real time. Zoho Survey is also popular. Kobo Correct Toolbox is also popular. So those days have really gone where people, have to deal with physical questionnaires, because physical questionnaires are good, but they can be very expensive. In terms of using them for research, they can be very expensive, and especially when you have a sample size that is very big. Imagine having a sample size of 500. How do you want to make questionnaires of 500? That's a lot of cost, especially when this research is not funded, they are out of pocket, paying kind of research. So online survey tools can actually help you save a lot of money, because now you just send the link to the participants and they're able to fill. And another good thing about the online survey is that as they are filling this tool and submitting, it's putting them in like a spreadsheet, like an Excel sheet, that is already ready for importation into your statistical software, so that you can begin data cleaning and analysis. Unlike when you use a paper-based questionnaire, where after you've collected the data, you now start entering the data into Excel or SPSS or whatever database that you're using for that purpose. So that's for the quantitative. So for the qualitative, we use what they call like an in-depth interview guide or a focus group interview guide. So for the in-depth interview, you talk with the participant one-on-one. That's why it's called in-depth interview. It's one-on-one, you and the participant. And you're able to record the session using a recorder. After you finish recording the session, you can now transcribe that session to a text. You can now transcribe that session to a text. Then, apart from the text, you can now put it into a qualitative tool like InVivo or whatever qualitative tool that you're using, so that you begin to analyze the thematic areas of that text. So if you're not doing an in-depth interview, another option is the focus group discussion, where you're going to be asking individuals questions in a group. All right. At the end of the day, it will still be recorded, transcribed to a text. Then you can now carry out the thematic analysis. So choosing a data collection method, it will depend on number one, the research question. Like I mentioned, if you're doing a study where at the end of the day, you'll be checking for patterns, prevalence, incidence, and those sort of things, definitely you're going to be using a survey or a questionnaire. But if you're going to be checking for things that you can't measure in terms of quantity, like I was talking about strategy, like if you say strategies that might improve the utilization of effective dietary patterns, may benefit from interviews for richer insight, because there's no way you can use a data collection tool questionnaire to measure strategies, because a lot of things are involved, and they are going to be giving you different sides on what they think can improve the utilization of effective dietary patterns. So if it's those kind of things you want to observe, then you'll be going for the interview. But if you're going to be measuring quantity, how many of the children are affected in terms of numbers, you're going to be counting them. So that will give you quantity. At the end of the day, it will give you prevalence. But if you're checking it over time, then it will give you incidence. So, but if you're going to be checking things like, that you can measure in terms of quantity, then you're going to be interviewing them so that you get richer insight. So another thing that also can influence this is the time, the budget, and the personnel you have. For example, if you want to collect the data in a shortest possible time, definitely you're going to be doing survey. Survey is faster to do, because you're just going to be administering the questionnaire. You're going to be sharing a link and they fill and share with you, and also the budget. If you don't have much budget, then you're going to be looking at the two. If you're doing the in-depth interview, you know that you are going to be keeping people I think an in-depth interview, minimum for an in-depth interview is usually like between 45 minutes and 60 minutes, you know. And if you're going to be keeping somebody, you know, talking for 60 minutes, then trust me, you are going to be giving them some form of honorarium for their time. Unlike a survey tool where you're going to be sending it in the link and they will probably not be interfacing with you one-on-one. But that may change if you are going to be doing, you know, an interview with the survey. So more like you feel like the people that you're going to be giving the questionnaire, maybe they may not there may be some kind of language barrier, and you think that if you give them the survey for them to just fill, whatever response you may get may not be complete or may not be adequate. In that instance, sometimes you may want to interview them and ask them the questions yourself and tick the questionnaire yourself. So those are instances where you as the researcher may interfere. But most times for surveys, you just send the link or you give them the tool and they fill and give back to you. All right. So the one you give them, they fill and give back to you is usually called self-administered. I know you've heard of self-administered questionnaire. You give them, they fill and they give back to you. Why the other one that you have to interview them and fill it for them is called interviewer administered questionnaire. So whichever option works for you, it's fine. So now we'll look at measurement. Now this tool that you're going to be giving, there are processes in measuring them. All right. Now you're going to be deciding or defining how you want to assign the numbers, how you want to assign the variables and the labels. All right. What type of specific measurement criteria you are going to be using, so that when you analyze them, it's going to be giving you the outcome that you are really, really interested in. Because analysis is more like a summary of all the response. So if you don't define your variables very well, in terms of how you're categorizing them, in terms of the type of numbering you're using, which I will show you as we go, when you analyze them, you may not be able to get the result that you want. So, level of measurement, which have a role to play with the units of data that you're going to be collecting with this tool. All right. So the first one is the nominal data. Now, any data you collect that does not have an order, no variable, no value is greater than the other in terms of the variable. All right. So when I say variable, I'm talking about the name itself. Then when I talk about value, I'm talking about the units that are there. So for nominal, the units are not increasing, they are not decreasing in any way. They are just there. That's why they are called nominal. The example I gave here is like blood types, A, B, and O. These are values. A is not higher than B is not higher than AB is not higher than O. They are just nominal. Another example is like sex, male or female is nominal, normal data, meaning no value is higher than the other. That's why it's called nominal data. Even colors, red, green, black, they are nominal data. Those kind of questions you ask where they either answer yes or no, they are nominal data. There's no order, there's no increasing, there's no decreasing. So nominal is part of the measurement that you'll be considering when you want to collect your data. So are you going to be collecting a nominal data, or you're going to be collecting an ordinal data, which is the next step? So an ordinal is a data that has levels. It has ranking. Wherever it is in any part of the world, that order exists. For example, pain scales have order. Either there's no pain, there's mild pain, moderate pain, severe pain. All right. Another example of this ordinal is educational level. Either you have no formal education, primary, secondary, tertiary. Anywhere in the world, educational level has order. One is higher than the other. That's why for job vacancies, they will always state it there. Minimum qualification, master's degree, PhD, or whatever. So there's no way you would see a job interview and they say, especially like for postdoctoral now, for you to do a postdoctoral, you must have a PhD. So you can't see a postdoctoral vacancy and you have not done a PhD, you have a master's, and you now apply with a master's. And what is your justification for applying with a master's is, even if you've not done a PhD, you feel that you have the same level of thinking as a PhD student. That's what is motivating you to apply for a postdoctoral position without a PhD. Trust me, you're not going to get it, and they're not going to call you for any form of interview. The reason is that there's an order. For you to do a postdoc, which is a higher level, you must have done a PhD. For you to do a PhD, you must have done a master's. For you to do a master's, you must have done a bachelor. So variables like this have order now. Why there are variables that are usually called interval, and every interval has equal, like 0 degree, 20 degree is an interval, meaning that 0 degree, for you to go to 20, it means 20 is 20 of 0. 30 is 30 of 0. That's why it's called interval. It is increasing. All right. So it moves from one level to another. That's why it's called interval. It grows from one level to another. So if you're increasing your temperature from so-so level to so-so level, it means it has increased by an interval. So it is you now that will decide what interval are you increasing it by. Is it by 2, by 4, by 6, by 8? But there is an interval increment. The final one is the ratio, which is a true 0 point, which you don't have for interval. Like interval now, you have a 0 degree, and that 0 degree is enough. It doesn't, like say now, if you have 0 degree and 20 degree, 0 degree doesn't mean there's no temperature. There's nothing happening at 0 degree unless you increase it to 1 degree or 2 degree or 3 degree. No. Interval simply means you are increasing the level, whatever level it is, there's something happening at that level. But you've chosen to increase that level by 2, by 4, by 6, or whatever you decide, by 20, by 30. Unlike the ratio where there's a true 0. So meaning that 0 kg means there's no weight. Unlike interval where 0 degrees Celsius does not mean there's no temperature. But for ratio, there's a true 0, meaning when you say 0 kg, everybody in the world knows that there's no weight. That's why it's 0 kg. 1 kg simply means the weight has increased from 0 to 1. So the weight has started counting, so that is how it works in the different levels of measurement. This part is very, very important, especially for those that would be designing, when you want to collect your data, I always recommend that students check for validated tool out there. There are a lot of things, like when you're measuring, when you want to do a study like depression, the Beck depression inventory is there, the PHQ-9 is there. There are a lot of tools for measuring depression. All right. There are a lot of tools for measuring different things. So when you want to do a study, what I always recommend students is, first of all, check online if there's a validated tool. If there's a validated tool, then you don't have to create your own questionnaire. Because when you create your own questionnaire, you have to validate that tool that you have created. You can't just use it that way. That's why it's good to check. I think WHO has, like, if you're doing a study now on quality of life, WHO has a validated tool for measuring quality of life. You don't need to design your own tool. So before you go ahead with designing your own tool, please check if there's already a validated tool out there to measure that the research outcome that you're interested in. If they are not, then fine. You can go ahead and design your own questionnaire. But you're going to be validating it, and you're also going to be doing, reliability tests as well, or measurement as well. So the process can be lengthy, but it can be done. Now, for the validity, it doesn't necessarily mean you have to do all of them. I'm just going to tell you what each of them means. You can choose one of them. Most times, what people do is the face validity. So the thing about the face validity is just there to ensure that whatever question you're asking people, how it sounds is what it means. That's what face validity is. You just want to be sure that what you're asking them is what it truly means. So if you're asking somebody, do you often feel sad or hopeless? Especially when you're measuring depression. When you say, do you often feel sad or hopeless? The person understands what sad means. The person understands what hopeless means. So when they are giving you a response, they are not guessing what does sad mean? What does hopeless mean as it relates to depression? They know. So meaning whatever answer they are giving you is an answer that is intended for the question you have asked that you want to measure. Sorry, I'm not. Okay, it's back. Sorry. Yeah. So so for the face validity, it means that for the question you want to ask, whatever you're asking them and whatever reply they give you, that is the response that you're intending to get. All right. So I remember there's this time we had this study that we wanted to do. So we had to do face validity, and this tool was to measure some maternal, maternal health issues. So they were for women of reproductive age. So we gave them the tool, and we realized that some of the questions we asked them, they didn't understand it. It was not clear. So we had to go back and look at those questions again. So that is what the face value, you have to ensure that when you ask people a question, do you often feel sad or hopeless, or whatever you ask them, are you having ringing in your ears? Is this thing having, whatever response they give to you, you'll be able to tell whether the way you have asked that question and the answer they are giving you, if they truly understood the questions you are actually asking. So that's face validity. For the criterion validity, that one is slightly different. All right. You're measuring it as it relates to a gold standard. All right. A gold standard simply means that if you're using a particular gold standard to measure something, that thing you are measuring, that is how it's supposed to be. For example, that I gave here, 90% of those who screen positive on the tool are diagnosed by a clinician. Demonstrate strong criterion validity. For example, now you have this standard tool, and when you ask people questions from that tool, you will be able to use that gold standard tool to tell whether they have depression or not. Like in the tool that I used when I was checking for noise-induced hearing loss, I asked them some questions. All right. And based on the questions you ask them, you are able to calculate the result. And that result is supposed to give you 50%, 60%, 70%, 80%, 90%. All right. So imagine that apart from that tool, there is another tool, which is the gold standard tool that was being used. So you're able to compare your own tool you have designed with the gold standard tool to be sure that whatever you are using now to measure whatever you want to measure is assessing the same thing if you were to use a gold standard tool. So that's what the criterion validity means. So means that whatever tool you have, so it depends on what you want to measure. So let's say now, like the example I'm giving, the depression screening tool, there are a lot of them out there. But let's assume that you are designing a new one. So if you're designing a new one, then you will be able to, whatever response you get in that new one, and whatever response you get from the standard one, you are to ensure that both results are almost similar. If the results are not similar, then it means that your tool is not measuring what it says it is measuring. So that's the criterion validity. So it depends on the particular validity that you want to do. Are you checking your own tool against a gold standard tool? If that is what you're doing, then you are using the criterion validity to ensure that whatever question, let's assume that this gold standard tool does not have some questions that you would like to ask, and you have added your own questions to your own tool, but you want to ensure that the additional questions you have added in your own tool is not making your own tool weaker, or it's not deviating the patient from the things that you really want to ask them and what you want to find out. So you're going to be comparing yours with the standard tool just to ensure that you are still on track. Then the other one is the construct validity, which also measures the extent to which a tool measures the theoretical construct it is intended to measure. Meaning that in theory, it is said that so thing correlates with this. So a higher score means depression. A lower score means no depression. So you have your own tool and you have designed it. So your tool should follow that construct. Your tool should what? Follow the construct of the theoretical framework, meaning the theory behind that tool. Whatever tool that is out there, the theory behind the tool may say that as the numbers are increasing, it means the depression is increasing, or as the numbers are reducing, it means the depression is reducing. So if you're designing your own tool, it should follow that pattern. It should follow that theoretical construct. In other words, you should design your tool in such a way as your own numbers is increasing, so the depression is increasing. Or as the number is reducing, so the depression is reducing. You should not do your own in a different pattern. It has to follow a theoretical construct, something that is a standard. Your tool has to follow that standard. All right. Now, the final one is the content validity. That one is, I will give an example of, the tool I told you about I used to measure noise-induced hearing loss. I think I asked them like 15 questions. And I did a content validity, simply that you're asking these people 15 questions, all right? But those 15 questions are supposed to measure one thing, whether they have noise-induced hearing loss or not. You see, so you're not asking them the 15 questions because you want to measure 15 different things. No, you're asking them 15 questions because at the end of the day, those 15 questions are supposed to be pointing to one thing, which is noise-induced hearing loss. So that's what the content validity is, meaning that as you have designed that tool you have designed is supposed to measure one thing or something. So you have to ensure that each of the items in that tool is measuring what it says it's supposed to measure. So that's the content validity. So you have to assess each of the questions to ensure that if each of the questions is supposed to be, if you have like 5 questions that are supposed to measure mood, 10 questions that are supposed to measure sleep, maybe 8 more that are supposed to measure appetite, you review those questions to ensure that those things that you want them to measure as a group, that's what they are measuring at the end of the day. That's why if you have those kind of tools and first you've done the content validity, they will now ask you to do like a reliability where you have a Chromebus Alpha. Now that Chromebus Alpha is supposed to tell you if that 10 questions are focusing on the same direction in measuring noise-induced hearing loss or in measuring depression in the participant or not. If the Chromebus Alpha is below, because the Chromebus Alpha is between 0 and 1, meaning 0.0 to 0.9. 9 means 90%, 0.3 means 30%. So if you're having a Cronbach's alpha of like 0.3, it tells you that it is only 30% of those 15 questions you're asking that is truly measuring noise-induced hearing loss. If you have a Cronbach's alpha of 70, which is good, which is strong, it tells you that it's about 70% of those 15 questions that is actually measuring noise-induced hearing loss. So we usually aim for Cronbach's alpha that is really high, because a Cronbach's alpha that is 0.8 or 0.9 simply means almost all of those questions are actually measuring what it says it is measuring. So this is the reliability. And apart from that Cronbach's alpha, which test where we use the Cronbach's alpha is the internal consistency. So Cronbach's alpha is used to measure internal consistency. You want to ensure that each of those items are measuring one thing. So all of the items in the depression scale is measuring depression. All of the items in the noise-induced hearing loss is measuring noise-induced hearing loss. So Cronbach's alpha checks for internal consistency if all of the items are measuring the same thing. But there are other aspects of reliability, like the test retest. All right, what is the test retest? An example is you have an anxiety survey you have done, and that anxiety survey tool you have designed, it's supposed to measure if they have anxiety or not. So what you do is that you gave the same participant the tool, and they will fill the tool. Then later they will fill the same tool again. So if the participant fills the first tool and scored 80, and they fill the tool again the second time and they are scoring 30, it means that something is wrong with that tool. The tool is confusing. The tool is not clear. The tool is not measuring what it says it is. So the participant is actually struggling to understand the questions. In the first instance, they probably guessed a lot of the questions. That's why they got 80. In the second one, they probably did not want to guess. That's why they got 30. So when you see that the test and retest is not showing the same score, it automatically tells you that something is wrong with that tool. You have to go and look at the individual questions again. There's another one they call the inter-rater. That one, you have to have the same persons that have the same profession to actually use that tool. And most times they use it for equipment like blood pressure equipment, stethoscope, thermometer, and the rest of them. It's you want to use that blood pressure speed for research. So to ensure that equipment is working so that you can record the values, you do like an inter-rater, meaning that you have a first doctor that will use it to measure blood pressure of the participant, then another doctor will measure the same blood pressure. That way, for the same participant, that way you're able to tell that that tool measures the same thing no matter how many times you use it. So if you're using the tool to measure, and every time, one time the blood pressure is 30, another time the blood pressure is 80, another time the blood pressure is 120, the same tool, it tells you that something is wrong with that equipment. It is not reliable because the inter-rater verification or assessment is not correct. So the other one, which is the split half, is you compare the result first and second. Probably you have like 10 quiz questions. All right, so you test the first 5, then later you test the last 5 of that quiz, because this is almost like what I described before. This tool, you have some questions, and all that questions are supposed to be measuring the same thing. So meaning that the first 5 questions is supposed to measure the same thing, the second 5 questions is supposed to measure the same thing. So if the first 5 questions is giving you a good score of 100% and the second 5 is giving you a poor score of 20%, it means that those 10 questions are not measuring the same thing. You have to go back and look at those questions. So these are forms of validity and reliability that we usually do. Although you don't have to use all of them, you can choose one. Majorly, what I use personally is the internal consistency, because I can use a statistical software to actually run the Cronbach's alpha. So it saves me time and it saves me all this headache All right, but for those of us that may not be able to do the internal consistency using the statistical software, they may now, think of other manual methods. All right, so the measurement tool, some of them, that's when I said the measurement tool, apart from the equipment, the one we usually use, which is the questionnaire or the survey tools, sometimes they can have a Likert scale. I will show you an example. I had also talked about the biometric devices and how you can validate them. I just gave you an example, the inter-rater. All right, sometimes it can be a checklist. You use a checklist for observational study, like I told you in the beginning. You just go there and check, are they wearing headgear? Check, are they doing this? Check, is the sound pressure level above or below 85 decibel? Check. So checklists are usually used for observational study. All right. Why the Likert scale? Sometimes it depends on what you want to measure. If you want to measure job satisfaction, you can ask them if they agree with a question, they disagree, or the rest of them. So we would see the tools now. I have an example of some tools. So this is an example of a questionnaire tool. All right. So you can see that I only pasted the section A and the section D. I think it was about 4 sections or 5 of them. So before you even go as far as designing the questionnaire, like I said, you already have in mind the problem you want to solve. From that problem you want to solve, you have crafted out your study aim and objective. Now, objectives, minimum is usually 5 study objectives. Now, those objectives, usually called specific objectives, are supposed to guide your research process. So what I tell my students is, because sometimes some students will hurriedly design questionnaires, take those questionnaires to the field, collect the data, come back, and now realize that the questionnaire tool did not address all of the study objectives. So if you hurriedly design your questionnaire or your study or your data collection tool and you go to the field, or you share the link and they give you the data and you analyze that data and now realize that, oh, one of the objectives was not captured. The only way to solve that problem is to go back to the field the second time. And trust me, nobody loves that. That's also not cost intensive. So in order for you not to forget any specific objective in your study collection tool, this is the advice I give to my students. Section A is by default social demographic characteristics. And those social demographic characteristics most times is dependent on the population. So the way it is here may not be the way it will be in your own. All right, but this is like a standard. You ask them their age, their gender, their marital status, educational level. Although here I have what is your, the name of your church, because the study I was doing was for, religious houses. So I had to take the name of the church. Now, educational level, and also the main occupation. All right. So it may change for yours. Musician was number 1 for me, contractor, oil company, depends. In your own case, the main occupation may change. Now, apart from the section A, which is the social demographic characteristics, and I advise that if you have 5 specific objectives, let your objective 1 be section B of your questionnaire, because section A by default is social demographic characteristics. Then you can now have your section B, section C, section D, section E. So specific objective 1 should be section B of your questionnaire. Specific objective 2 should be section C of your questionnaire. Specific objective 3 should be section D of your questionnaire. So you find out that if you do it like that, each of your objective is answered by a section in your questionnaire. That way you will not forget an objective. And that has really helped. So if you do it like that, you will not design a questionnaire and now realize that you forgot to capture one objective in your questionnaire. Which will mean removing that objective. And I doubt any of your supervisors will want you to remove an objective that is already approved. So the option for you will be going back to the field the second time. So please take note. So if you look at the section D, you will realize that I was measuring hearing difficulty, and I was asking them questions like, for example, have you gone for any hearing test or evaluation before? I have a yes and I have a no. Sometimes, well, someone asks quickly if social demographic characteristics can be objective one. Yes, it can be. Sometimes your objective one can be to explore the social demographic characteristics of the participants. Yes, I see those objectives, but trust me, that objective is not necessary, because at the end of the day, there's no study you will do that you're not going to assess social demographic characteristics. You know why? Because social demographic characteristics is a key component of every research you do. They can serve as confounders. You understand? And some conditions too that are age related, gender related, occupational related, you would also want to measure the social demographic characteristics against those outcomes you're measuring. Like in my study on noise-induced hearing loss, it is clear everywhere in literature that age is significantly associated with noise-induced hearing loss, meaning that the older you are, the more likely your hearing loss will increase. So there's no way I will be doing a study on hearing loss, I will not capture age. You see, and I will not capture occupation, because occupation has a association with hearing loss. If your occupation is a musician and you work in a nightclub or you work in a construction site where they're making noise every day, or the airport, you most likely have hearing loss. So occupation by default will be there. So you see that most times social demographic is by default. Whether you mention it in your specific objective or not, you're going to collect it after all. So I don't think you should waste your time capturing social demographic in your specific objective. Just capture other things, because by default, you're going to be measuring social demographic characteristics. Okay, so if you look at question 30, which is a follow-up to question 29, for those of them that said yes, I asked where they will mention the clinic, and sometimes it can be yes, no, and sometimes, depending on the way the questions would be. You know, so, and someone asks quickly how many questions that you use to, verify a specific objective. There's no standard. There's no standard. The questions can be between 5 and 10. However, if your specific objective is measuring knowledge, you can't measure knowledge with questions that are less than 10. Please take note. This is very, very important. If you're doing a study, for example, CAP studies, knowledge, attitude, and practice, the questions you're asking at the end of the day to capture whether they have knowledge of a particular area should not be less than 10. Knowledge question, because it takes minimum of 10 questions to be able to measure knowledge. So for my students that are doing CAP study, I usually recommend minimum 10 for knowledge, 10 for attitude, and 10 for practice. It should not go below. But for other things that has nothing to do with CAP, it should be between 5 and 10. Oh, sorry. I was muted. Sorry about that. Yeah. So this other question, like you can see, this is for Likert scale, and you see the social demographic characteristics there. You see? So like I said, by default, social demographic characteristics is there by default. Okay? So the other thing now that followed is the section B, which may likely be your first specific objective, customer-oriented behavior. Then you have your Likert scale. Question 8 says, I'm always working to improve the service I give to customers. Strongly disagree, disagree, somewhat disagree, somewhat agree, agree, or strongly agree. So you see the level. It goes from 1 to 6. So strongly agree, so meaning that if you look at the first question, I am always working to improve the service I give to customers. So meaning that higher score means customer-oriented behavior. Look at this number 9. I have specific ideas about how to improve the service I give to customers. So you see, anybody that says strongly agree, number 6, it means they have very good customer-oriented behavior. So the way this tool is designed, higher numbers means good customer-oriented behavior, while lower numbers means poor or bad customer-oriented behavior. So those are how Likert scales are designed. You design it in such a way that increasing number means something, while reducing number means something. All right? It's unlike other kind of question that is a yes and a no. So Likert scale in the scale of measurement is under ordinal, because there is an increasing order or there's a decreasing order. Okay. Next slide. Okay, so importance of good measurement that we have been talking about. One, accurate interpretation. The reason why you do all this reliability, validity, and all these things I've been saying is the fact that when you ask somebody, how old are you? You know, look at it this way. You know, a lot of times we treat age as if it's a discrete variable. You know, we have discrete variable, we have continuous variables. Now, discrete variables are numbers. They don't have decimals. That's why they are called discrete number. Number of children, that's discrete. It doesn't have decimals. All right? Number of cars is discrete. Either you have one car or two cars. All right? It doesn't have decimals. But there are variables that have decimals. That's why they are called continuous. Now, example is like weight, height, BMI. They have decimals. That's why they are called continuous. But you know that a lot of times we treat age as if it's discrete. You ask somebody, how old are you? And the person will tell you, I'm 20 years old, or I'm 30 years old, or I'm 21 years old. The truth is, you can only be 21 years old if that day is your birthday. You can only be 30 years old if that day is your birthday. So if someone is asking you how old you are on a day that is not your birthday, it simply means you're 20 years old and 1 day, or you're 20 years old and 5 months, or you're 20 years old and 8 months. You see, which is why for accuracy in interpretation, I always recommend that instead of asking people how old you are or how old are you, you ask people, how old are you on your last birthday? Because if they are not telling you how old they are on their last birthday, then whatever age they are giving you is not correct. So it's all part of the accurate interpretation. Don't be in a hurry when you're designing, which is what I always recommend. Don't always be in a hurry to design your tool. Take your time, design it, validate it, ensure that whatever question you're asking anyone, the answer they are giving you is actually an answer that is supposed to accurately address that question. So you see people go to the field with a questionnaire they just designed, they didn't test, no pre-test. You know, pre-test is also a part of face validity as well, where if you take like 10% of your minimum sample size, let's say if your minimum sample size is 200, you take 20 of those questionnaires, you give a different population that is not the population that you collect your original data from. Let's say you're going to be collecting your data from women of reproductive age in hospital A. So to do a pre-test so that you can validate, you can give 20 of that questionnaire to women of reproductive age in health center J, a different health center, but the same characteristics of women, so that they can fill the questionnaire. So in filling the questionnaire, you will see that they're going to be asking you some questions. Sir, this question, what does it mean? You know, from their responses and the way they are feeling, you'll be able to tell that you probably didn't ask those questions very well. What you're asking something else, and they're actually understanding it in a different way. So accurate interpretation matters, because if you don't get the accurate answers to the question you've asked, then you're definitely going to have poor measurement. No matter what you're measuring, it will not be correct, and that will jeopardize research integrity. Trust me. And whatever recommendations you're making from your findings will not be correct.
nako ngenda bakama ubundi ntabwo mba numva hari ahantu izuye nawe
mbese hari uko bajya bakabishyura
yewe uretse ko hano uzi ko nawe uhora abyibushye none nagiye ntabwo ideni ariko si byaba ryatswe na korode ryatse korode kari umukobwa wari uhari umukobwa arabitwima pe hasi ubu kuko nazanye n'umuntu
Who is talking? Okay, thank you. So we are diving into sample size, because this is another place, where a lot of students have issues, because at the end of the day, you want to collect your data, but how many do you collect? It's not clear. Someone is asking date of birth. Well, the issue with date of birth is you will now be the one calculating the age. I'm not sure you want to do that there, because asking 200 people date of birth and they give you the date of birth, no problem. But you're now going to be using calculator to calculate how, because you won't be able to analyze date of birth. You can only analyze age. Either you're analyzing the mean age or the median age, or you're categorizing the age and analyzing it in frequency and percentages, but you can't analyze date of birth. So it means at the end of the day, you're going to be using your calculator and converting the date of birth to real age. And trust me, that's a lot of work. So there's no need. Just ask them their age. All right. Yeah. So introduction to sample size. So let's look at this. So like I said earlier, if you want to go and collect your data, you have to know how many data you're going to be collecting, right? You can't just go to the field and carry 200 questionnaires to the field, or carry 10 survey field. No, you have to be systematic. And as long as you're doing research, they have said that there are systematic way, the same way there are systematic way in creating your data collection tools and all that. There are systematic ways in calculating sample size. You don't just decide the number to collect. So I had said that in the age at last birthday, previously. So age, ask them age at their last birthday. All right. So they will tell you the exact age at their last birthday. It can be 30, 40, 20, or the rest of them without the decimals, that are there. Okay. So for you to calculate sample size, you have to look at statistical power. Now, this is very, very important because it guides sample size determination. Now, there's a portion in scriptures in Proverbs 24 verse 10. I like quoting it. It says, if you faint in the day of adversity, your strength is small. That also applies to statistical power. So if you're doing an association of two groups and you don't find a statistical significant difference, check on your data. It probably means the power for that data is small. So meaning that the number is probably small. It doesn't have enough power to show a statistical significant difference. If a statistical significant difference is there, let's look at this example, which is from our own work. We did a pre and a post intervention. This is electronic medical records. It's a more like a project that is ongoing in most of the states here in Nigeria, and I'm helping to do monitoring and evaluation. So we did like a pre and a post test. Okay, look at the number for the pre-test, 52. Look at the number for the post-test, 27. So we didn't pay attention to statistical power. We didn't pay attention to sample size. We just use whatever we can find. And at the end of the day, look at the way the data is looking at. Correct. So before they were trained, their correct definition of electronic medical record was 80.8%. But after the training, it increased to 85.2%. Look at the second one, common electronic medical record features. Their knowledge comprehensively of it was only 25%. But after the training, it increased to what? 40.7%. But how come an increase from 25% to 40.7% did not show a statistically significant difference? Now, the test we use to check for the difference in the percentage is McNeema test. Now, we didn't use a chi-square. Like, I don't know if I'd mentioned this. If you're checking for differences in percentages, the test of significance to use is the chi-square. That's the standard. But that is only for independent, when you're checking for differences in independent percentages. But this is pre and post, more like paired. What happened before the intervention and what happened after the intervention. So it is the same, almost like the same population. So when we're doing the training for the pre-test, 52 people filled. But after the training, only 27 filled, which is far lower than the number that filled the pre-test. So because you're checking for differences in paired between pre and post, the test of significance to use is called McNeema. All right. You know, this also applies if you're checking for differences in means. In two means, you use paired student t-test. You remember, if you're checking for differences in two means from a pre and a post, you use paired student t-test. But if you're checking for differences in two means that are independent, you use the independent student t-test. So that's the same way it is here. If you're checking for differences in independent percentages, you use chi-square. But if you're checking for differences in paired percentages, like a pre and a post, you use the McNeema. So our McNeema test, which is like a p, value, did not show any, meaning that none of the p values was statistically significant. All of them was greater than 0.005. So why is this so? Does it really mean that there was no improvement after the training? No, there was an improvement after the training. Look at the second one, 40%. That's a huge improvement. But that increase did not show a statistically significant difference because the statistical power is small. Small because we didn't use adequate sample size that is able to show us a significant difference, if truly a significant difference is there. So that's why it's very important to ensure you have enough statistical power by calculating your sample size. Because if you don't calculate adequate sample size and you just use any number you find, the association may have a significant difference, but because your power is small, it will show as if there's no significant difference. And that way you'll be committing a type 2 error. What is type 2 error? Type 2 error is when you're supposed to reject the null hypothesis. Why are you rejecting the null hypothesis? Because there is a significant difference. There's a significant difference that you're supposed to reject the null hypothesis. But you're not rejecting the null hypothesis now because it's showing that there's no significant difference. And the only reason why that is happening is because your power is small. So you're committing a type 2 error. So what is statistical power really? It is defined as the probability that a study will detect a real effect if one actually exists. So in that example I showed you, I have a feeling that there is a real effect, meaning that there was a difference in the training, meaning the intervention was impactful. The training we did was impactful, but because the power was small, we did not see any statistical significant difference. So statistical power is the probability for a study to detect a real effect. If that effect is there, it will show you. So if there's a significant increase from one percentage to another, if there's a significant mean increase from one level to another, the p-value will be significant if it's truly there, because you have enough power, enough sample size to actually detect that difference, if that difference is truly there. So statistical power is power equal to 1 minus beta. So the beta is the probability of making a type 2 error. I've described a type 2 error. A type 2 error is when you're supposed to reject the null hypothesis. What is the null hypothesis? There's no significant difference between the pre and the post intervention. That's our null hypothesis. We've done the research. There's supposed to be a significant difference. But because our power is small, we are not able to reject the null hypothesis because the p-value is not significant. So the inability for you to reject the null hypothesis when the null hypothesis should have been rejected, it's a type 2 error. And it's only caused by when your sample size is small. And most of us would have experienced this. You're doing a statistical analysis and you're saying that most of your association didn't show a significant difference. Most times it's because you didn't calculate sample size or the sample number you're using is small. So what are the tools for calculating sample size? I will show us just 3 methods. There are others using EpiInfo, which is an epidemiological software, using GPower, and also the manual way of doing it. So I don't know how many of us use EpiInfo. Okay, the next slide. Yeah, next slide, please. Yeah, so EpiInfo, I don't know if you download EpiInfo. EpiInfo is free. If you download EpiInfo, I think we have 7.02 version now. It's free. You know, EpiInfo is very free. You can go to you can just Google download EpiInfo. It's a statistical software that is designed by WHO and the Center for Disease Control. It's been free. I have been using EpiInfo since 2000. So I've been using EpiInfo for like 25 years now. We are in 2000 and we're in 2025 years. So I've been using EpiInfo for like 25 years now. So it's a tool that has been there for a long time and it's still free to date. It's just that a lot of people are so crazy about SPSS and other statistical software. Why this one works, and I use it a lot. And this is actually the software that is designed for public health students, epidemiological students, not SPSS. SPSS is actually a social science software, you know. So if you install EpiInfo, there's a place in that EpiInfo they call StatCalc. So when you go to StatCalc, you will see the different sample size calculation formula. So see up here, if you check up here, you will see population survey. When you click the population survey, it will give you the format. So if you're doing a study, which is a population survey, like a prevalence study, all right, you can use this population survey to calculate the sample size. All you need to do is to have an idea what the population size is. This population size may not be the real size. It may be a guesstimate, all right? It doesn't have to be the real size. If you're able to get the real population number, beautiful. But if you're not able to get the exact population size, then you have to guesstimate, all right? Then the expected frequency of the condition that you're measuring. Like if you're doing a study where you're looking at prevalence of malaria or prevalence of depression, then you have to find a previous study that measures prevalence of depression. Then it is here that you are going to put that, frequency or that percentage. You're going to put it here, either 20%, or 10% or whatever it is. So you are going to put it here. Then tolerable error is usually 5% by default. So any sample, any minimum. Now, you have to appreciate the fact that when we are calculating sample size, what we are calculating is minimum sample size. So meaning whatever number you have, whatever number that is generated, that's minimum sample. It can go higher than that, but it should not go below that. So that's why they always give an acceptable margin of error, also called tolerable error of 5%. So you use the tolerable error of 5% to calculate your minimum sample, and you get 200. So when you have 200, it means that you should be able to get 200. If you get 190, it means your tolerable error is no longer 5%. It has increased to 8% or 10%. So that's why it is not, you can find expected frequency from a literature, from a previous study that is similar to your work. Like I said, if you're doing a study on prevalence of depression or prevalence of malaria, look for a similar study in your own setting or in your own region that did something similar to what you want to do. Check whatever prevalence they got in their own study. That is the prevalence that you're going to put in the expected frequency. Then 5% is by default. Then design effect. Design effect is not compulsory. Okay? Design effect simply means that you want to multiply whatever minimum sample you have. So if the minimum sample is 200, you want to multiply that 200 to 400, then you can increase the design effect by 2. It depends on you as the researcher. Design effect is not compulsory. You can leave your minimum sample the way it is. Whatever it calculates for you, that's what you're going to use. All right? But most of the time, if you're doing a cluster study, like I mentioned, cluster simply means a study where you're taking a similar characteristics, like you're collecting your data from a different health centers. You're collecting your data from different schools. These are clusters. Imagine you have 2,000 schools and you're only collecting the data from 5 schools. They will feel that 5 schools you're collecting the data from is not truly a representative of the 2,000 schools because there are more. So in order to minimize power or error, in order to ensure that you have adequate power to measure whatever you want to measure, they will say, okay, have a design effect of 2 or have a design effect of 3. So meaning that if you have your minimum sample of 200, you times it by 2 or you times it by 3 so that you have more numbers because you're dealing with clusters here. But if you're doing a study and it's not a cluster study, please leave your design effect as 1.0. You don't need to multiply by anything. All right? So if the design effect is 1, it means the cluster will be 1. All right? So that's how it works. So if you check at this side now, it will give you the sample size depending on the confidence level interval. The confidence level interval that is required is between 95 down, not up. 80% is usually not recommended. 90% is usually not recommended. So it's 95% confident that the whatever minimum sample size you have adequate power to detect the difference if the difference is there. That's what this 95% confidence interval means. So you can't say your 90% is usually not acceptable. 95% should be the minimum. And you will notice that as the confidence interval is increasing, that's how your sample size is also increasing. You will notice that. So taking a thinner confidence interval means you're ready to do more work by having more numbers. So 95% is fine. So based on a prevalence of 20%, your minimum sample is 197. So when you have this minimum sample of 197, they will now tell you to add a non-response of 10%. 10% is usually recommended. You can add 20% if you want, but 10% is fine. which will now increase that number a little bit. I think we will talk more on that when I show you the manual calculation of sample size. So if you're not doing a prevalence study and you're doing a cohort, sorry, I said if you're not doing a population study and you're doing a cohort or cross-sectional study like I discussed last week, then you can use this one. If you're doing a case control study, you can use this one. The principles are the same, all right? But when it comes to population study, you're dealing with the frequency, that's the prevalence. But when you're dealing with like the case control, then they will be talking about power. And the same way your recommended confidence interval is 95%, your recommended tolerable error is 5%. These things are like default. Your recommended power is usually 80%. You should not go below 80%. 80% power is usually like the limit. You can have 85, you can have 90%, but the more the power, the more the number. So you can do 80% power, which is like the minimum. Then the ratio of control to case, that depends on you. If you want the ratio of the control to your case to be 1:1, meaning for every 50% case, you need 50%. Sorry, I say 50%. For every 50 case in terms of population, you're using 50 control. So people can do 1:1 in terms of case and control. Some people can do 2:1, meaning that if you have 100 control, you will have 50 case. It depends on you, but it should not be more than 2:1, please. Meaning the control should be more than the case by 2 points, okay? But you can do 1:1, all right? Meaning for every 50 case, you also have 50 control, okay? Then the percent of controls exposed, you are going to get this from previous literature, all right? So the control will have an exposure. So if you're talking about noise-induced hearing loss, that's if it's a case control study, you will see a study where they are saying 10% of the population were exposed to noise, to dangerous sound pressure level exposure. You will get it from previous study. So you put the percent of the exposure you find for the control group. Then for the case group, it will be the odds ratio because it's a case control study. So if you check previous case control study, you will see the odds ratio, meaning the odds of the cases having the condition that you're measuring, the odds of the cases having noise-induced hearing loss, the odds of the cases having depression, the odds of the cases having malaria. Is it 2:1? Is it, sorry, not 2, is it 2.1? So odds ratio of 2.3 simply means that those that are in the case or those that are cases are 2.3 times more likely to have the outcome you're interested in. So you find these things in previous study, and also the percent of exposure for the cases, you also find it in a previous study like you do for the control. So put all those values here, it will now give you the number. So it will give you the number for the case, the number for the control, then give you total. The same thing with cohort. Cohort and case control, you have a case, you have, like for cohort, you have an exposed population, you have an unexposed population. But for case control, you have those that have the case and those that do not have the case. So the principles work alike. So for G-Power, I've given a link where you can download the software. As at the last time I used it, it is still free, and I think it's still free. So you go to that link, you download it, you install it. I've highlighted the places to install, then you click install. Then once it's installed, when you open the software, which is in the next slide, you will also see that it looks like the EpiInfo that I just described. So you will just put the values and it will give you your sample size. So one thing with the G-Power is if you come to this place, you will be able to choose exactly the type of power and also the type of studies, like the statistical test that you'll be checking for that your particular study. So you can actually choose the options here for the statistical test. Either you're going to be doing a correlation or whatever that you're going to be doing, and also you're going to be choosing the type of power, which I just mentioned. Then if you look at this place, these things here, they are default. All right. If your tolerable error is 5%, it means your power will be 95%. All right, in this case here. But don't go below 80% for your power. I keep saying that. Don't go below 80%. You can go higher. All right, but tolerable error by default is 0.05. All right, the effect size, it depends on what effect size you want to use. 0.1, which there's none, 0.2, which is 2 times, 0.3, which is 3 times. So it depends on you. I've mentioned the effect size, which is only applicable when you're doing cluster. Okay, now if you look at here, the power is 0.84, while the power here is 0.95. So I was like showing this, but I later changed the power here to 0.84, and if you look, it gave me a sample size of 71. A minimum sample size of 71, because this sample size I calculated, I am looking for differences in 2 independent means. All right, meaning that I'm calculating a sample size where I want to check for differences in means, so it will be 2 groups. All right, so if you look here, it gives me the first group will be 71, the second group will be 71. So these things can be calculated manually without using a software. So let me show us how to calculate manually now. All right, so this is the sample size for if you're doing a study like a cross-sectional study where you're checking for prevalence. This is the sample size that you're going to be using. So let's look at it clearly in the next slide. So in your next slide, this is the way it looks. A lot of us know this formula. Sometimes you call it the Cochrane formula. Okay, so the textbook where I got it from is called Kish. All right, Z square PQ over E square. So for those of us that are doing cross-sectional study, which will most likely be a prevalence study, this is the sample size determination formula that you're going to be using by default, because your study involves measuring prevalence. So Z is a constant, 1.96 at 95% confidence interval. Z is a constant. P is what you're going to be looking for, meaning you're going to be looking for prevalence from a previous study. Now, Q is 1 minus P. So if you have your P, you can calculate Q, which is 1 minus P. E is default, tolerable error, 0.05. All right, that's the tolerable error. That's the allowable tolerable error. All right, 0.05. So let's look at the next slide for how to calculate these things. So let's assume that you are doing a study where you want to measure prevalence of institutional delivery service utilization. That's your own study now. So meaning you want to look at the prevalence of women that delivered in health centers. So what you do is you're going to find a study that has been done in your region. Then look for the prevalence for that's your objective, because one of your objectives will clearly be prevalence of institutional delivery service utilization. That will be one of your objectives if you're doing a cross-sectional study, because a cross-sectional study is most likely a prevalence study. So you look for a previous study and look for the prevalence. So for this study, we found the prevalence is 38%. So it is this 38% that we will now be replacing our P with. So if you look at the formula in the next slide, you will see that everything is a constant. The only thing that changed is the P. So our Z is still 1.96. Then our P now, we are now stating where we got our P from, the study that I just showed you. Then the Q is 1 minus P. The tolerable error is 0.05. So you put everything in the formula. So the 0.38 now, which is the 38%, would be in the formula. Once you calculate, you will now get 362. 362 is your minimum sample, but it's usually recommended to add a 10% non-response. Now, the reason why they do this is because you have calculated this minimum sample with a tolerable error of 0.05, you are not allowed to go below 362. You are not allowed. So the chances are, if you go to the field with 362, you may likely come back with 360. You may likely come back with 358. You may even likely come back with 350. And as long as the sample size you come back with is lower than the minimum sample you calculated, it is not acceptable, because for the fact that that sample you're coming back with is not 362, your tolerable error is no longer 5%. Means your tolerable error has increased to like 8% or 10%, and that's not acceptable, because you have stated that you're going to be calculating the minimum sample at a 95% confidence interval. So you're 95% confident that 362 is going to measure whatever effect that you're checking, and it's going to give you an accurate result, meaning 362. Okay, 362 has adequate power. Please, can we go back to the previous slide, please? I want to show somebody something. The 38% is from a previous study. See it there in the results section. Only 38% of study participants deliver the index child at health facility. So 38% is the prevalence from a previous study. So I'm saying that if you're doing a study on institutional delivery service utilization, then you have to find a similar study in your region and check what the prevalence is for that outcome you're measuring in your own study. So is that 38% now that you're going to put in your P to be able to calculate your minimum sample? Yeah, thank you. All right, so in order to avoid students from coming back with lower minimum sample than they went with, they said add 10%. So when you add 10% to 362, it's going to give you 398. All right. Imagine going to the field with 398. Even if 10 people did not respond to you, you will come back with 388. That's still above your minimum sample. So you see the trick. So the reason why they say add 10%, so that if you go to the field with more questionnaires than you need, you will likely come back with more questionnaires that will not influence your minimum sample size. So non-response applies to prevalence studies, cross-sectional studies. But if you're doing a cohort study, it's not called non-response, because cohort study is a follow-up study. Because in a cohort study, you expose participants and you follow them up to see whether they will develop the outcome you're interested in as a result of that exposure. So they call it attrition. So for cohort studies, you are going to say for a 10% attrition. But for cross-sectional study, it's called non-response, because the participant will decide to respond or not to respond. But for cohort study, there's nothing like responding or not to respond. It's usually lost to follow up, because you're going to be following them over time, and some of them will drop along the wayside. So that's why we use attrition for cohort studies instead of non-response. So I just want you to know the difference. So if you're going to be comparing two prevalences, then this is the formula that you're going to be using, from the textbook Keckwood. All right. So this is the formula. So this formula here, everything is a constant. The only thing that you're going to be looking for now is your P1 and your P2. So imagine this study now that I just showed you, where you're looking for prevalence of institutional delivery. You can make that a comparative study, meaning prevalence of institutional delivery in a private health center, prevalence of institutional delivery in a public. So if you're now doing a comparative study where you want to check whether there's more delivery in private than public, or whether there's more delivery in public than private, then you're going to be using this formula, because now you're comparing two populations. So you're going to be looking for P1, which will likely be prevalence from one facility, then P2 will be prevalence from another facility. So, but the example that I used here is different. So I used, just imagine you are doing a study where you are checking for serum selenium deficiency in two populations, HIV infected children and children that are not HIV infected. So you want to check which group have more selenium deficiency. Is it the HIV infected children or the controls which are not HIV infected? Which group have more prevalence of selenium deficiency? So if you're doing a study like that, you are going to go to the internet and find a similar study. So by looking for that similar study, you will read through. This study you will see that they found out that selenium deficiency for HIV children was 24.3, which is our P1. Why? Selenium deficiency for controls, meaning children that are not HIV positive, is 11.4. So in that our formula, our P1 will now be 24.3, our P2 will now be 11.4. Every other thing there is a constant. So we are only looking for the P1 and the P2 in previous studies. And also, I would like to add that it's not all the time that you will be able to find your P1 and P2 in one study. You can get your P1 and P2 in two different studies. If you're not able to find the P1 and P2 in one study, it's allowed. But those two studies have to come from the same setting. Hello? Those two studies have to come from the same setting, please, so that the result will not be too off. So we are going to put those numbers inside this formula. So our P1 is 24.3, which is 0.243. Our P2 is 11.4, which is 0.114. So put those P1 and P2 in this formula, it will give us 116. And you're going to now be adding your 10%. So whatever number you get now, which is after the 10% is 128. So whatever number you get is for each group. Please, students usually mix this up. Sometimes students will calculate this minimum sample and they get 128 and they will now divide that 128 by 2. Please, it's not correct. Whatever number you get from this formula, it means you're going to times it by 2, meaning that number is for one group. Please don't divide it to, it's for one group, please. I know that sometimes you feel, the number is too much. Let me divide it and share it. Please, it's not correct. Whatever number you get is for each group. So you times it by 2 to get your total population. All right, so for those of us that want to look at studies where we're checking for differences in means, all right, not like percentages that I've shown you. One of the formulas you can use is this one, all right? So you can see that everything here is a constant. The only thing that is not a constant is your S2, which is the standard deviation. So if you're doing a study where you're going to be checking for differences in means, you have to go and find a previous study that have a mean and standard deviation for the first group and mean and standard deviation for the second group. So this S2 is not mean difference, it's standard deviation difference. So, but you will not be able to see standard deviation if you don't find the mean. So if you're doing a study where you're checking for differences in mean, what the formula recommends is differences in standard deviation, not differences in mean. So you look for a previous study, wherever you have the mean, you will have the standard deviation at the side. So in this study now, which is looking for difference in mean absolute errors of the accuracy of ultrasonic and clinical method of estimation of fetal weight. So mean absolute errors. So the study had a mean absolute number and standard deviation of 9.48 for the first study. Then the other one has 7.61. So you do a difference between the first standard deviation and the second standard deviation. That's what will give you the standard deviation difference, which is what your S is. Then you now square it by 2. So every other thing here is a constant, including the tolerable error. All right. Then it will now give you your minimum sample of 131. You will now add your 10%, non-response, all right, to be able to get 144. So these slides will be shared with you so that you can take your time and study these things. So for qualitative study, we don't usually go this route. Qualitative study usually depends on saturation. You don't really calculate the number that you're going to use. You just keep interviewing until you get to that point where those that you're interviewing keep saying the same thing. It means you've gotten to the point of data saturation. All right, meaning that qualitative, you do in-depth interview, so you keep interviewing. You can interview 8, 9 persons, 10 persons, 11, 12, 13, 14, 15. There's a point sometimes when you get to 10, 11, 12, you now find out that most of them are repeating the same answer for the questions you've asked. So you know that you've gotten to what they call saturation level, data saturation, meaning the level where there's no new information again. Then you stop your in-depth interview. You don't interview anymore. So that's how you know your sample size for qualitative. The one is saturation principle. The other one is focus group size. By default, focus group size is usually between 8 and 10. Anything more than 10 will be difficult to manage. Some people do 6, some people do 8, some people do 10. So that's the standard, all right? So if you're doing focus group discussion, you're either going to be doing 6 or 8 or 10. It won't be more than that, all right? And sometimes the sample size often determined during the research process, which is what I just described now. This happens only for qualitative. As you're doing the study, you're determining your sample size. But quantitative, you will determine your sample size first, though, before you go to the field. So practical consideration, I've talked about the non-response. It can be between 10% and 20%, depending on your muscle, but you have to add it to your work. If you don't add the non-response to your work, you will go to the field with less questionnaires that you need, and that will affect the quality of your work. All right? Ensure that whoever is helping you collect the data, they are well trained, so that they won't be collecting data that have a lot of missing values. The next thing is your budget. This can also depend. So if you calculate your minimum sample with a prevalence of 38%, and you're getting a minimum sample size of 300 and something, and you find out that you're not able to get 300 and something participants, or you don't have the money or the budget to administer questionnaire to 300 and something, look for a study with a lower prevalence. So if you have a study that have a prevalence of 38 and you're getting a minimum sample of 300 and something, if you find another study that have a prevalence of 10 or prevalence of 12, that sample size will crash down. So that's the secret. So if you have a prevalence and the minimum sample you calculate is too big, find a lower prevalence from a previous study and they calculate the sample size, that number will drop. So another thing is the time constraint, which is the same thing with the budget. If that 300 and something will take you months to collect, you can do the same thing and crash the number so that it will take you less time to collect the sample. Next slide. All right. Your questions? Okay, so someone asked, the style of age range, what is your opinion in terms of accuracy, interpretation, and scaling? Well, my brother, my sister, there's no standard though. You can do age range of 5, you can do age range of 10. It depends on how lengthy it will be. If you're doing a study where you collected ages from 18 to 70, you can't afford to do age range of 5 because it will be too long. So you would definitely do age range of 10. But if you collected data from, let's say you are doing a study on hypertension A majority of the people now that you collect your data from for hypertensive studies will be senior citizens. So meaning the age range will not be too far apart, so you can do age range of 5. All right. But if you collect the data, like I said, from 18 to like 70 years, you can't do age range of 5. Oh, it will be too long. You most likely do 10. How do we find expected frequency? Like I said, I've answered this before. You look for a previous study and look for the prevalence of that previous study based on the outcome you're measuring in your specific objective. This only applies to those that are doing frequent prevalence studies. So if your study is measuring a prevalence of pneumonia or prevalence of diarrhea among children, you have to find a previous study that measures prevalence. Then that is the prevalence that you're going to use to impute in the sample size calculation. Any other question? You can unmute and ask your question verbally, if that's okay. All right. So are these the only questions on the chat box? Although I was seeing some of the questions, but are these the only questions? Please ask if your questions are not answered. We still have few minutes for questions and answer. Please ask so that I can clarify whatever. I know that sample size is one area that students always have. Those WHO, UNICEF, and others have standard measure for some cases. Yes, and I said this. Anytime you want to do a study, please confirm that there's a validated tool for that. Most studies you do, most of the outcome you want to measure, WHO already have a validated tool to measure those things. So you don't need to design your own. Because when you design your own questionnaire, if you go through, if you use it, and you collect your data and probably use it for your project, for your program, either bachelor's or master's, when you now want to publish that work, the reviewers are going to give you a tough time because they would want you to prove how you validated that tool, because that tool has to go through a validation process. So most times I notice in the undergraduate, they may let my people go. They may allow you to just go. But when you now want to publish that work, that's where the validation will now come step in. They will now be wanting to know, how did you validate that tool to ensure that it is measuring what you want it to measure. That's what validation is all about. Whatever question you're asking, whatever thing you want to measure, is that what the tool is measuring? That's what validation is all about. Do we have more persons asking questions? Sample size determination is a lot of work for a lot of students. I mean, I was expecting people to ask a lot of questions on sample size determination because I get a lot of questions from this area. It's a tough area, So please unmute and ask your questions on sample or any other aspect that I know. This is where most of the challenges is determining sample size. I get a lot of questions on that. Yeah, Philip is asking if I can review his final research project. Of course, I'm happy to do so. Yeah, so reach out to the FIRAT. They will be able to share my email with you. Of course, I can help you review. All right, it's no problem at all. Yeah, so where are the questions, please? So are you telling me you understood sample size very well? Are you sure? This aspect is tough. Eh? Okay, Francis is asking, well, my question is on effect size in meta-analysis, but I guess I can do that via, yeah. We're not looking at the effect size in meta-analysis is a whole different ball game. I'm not sure that I really want to talk that here. Yeah, so let us do that in another communication. Yes, I have a whole presentation on meta-analysis. I think I'll be able to help you with that. Yeah. Do you just use any previous study for prevalence value determination? Yes. As long as that previous study is not older than 10 years. I'm sorry, I forgot to mention that. Yeah, thank you for bringing that out, Olawale. Yeah. You can use any previous study as long as that prevalence is measuring the outcome that you're also measuring. You can't be measuring malaria and you're looking for prevalence in fibroid. Of course, it's not going to match now. Yes, as long as it doesn't matter the study. If you're conducting this study in Nigeria and you're conducting it in Lagos, then you have to look for a study in Lagos. And even if you're conducting the study in Lut, you have to look for a similar study that has been done in Lut. If there's no study done in Lut, you look for a study that is done in Lagos. If there's no study that is done in Lagos, then you look for a study that is done in the Southwest. If there's no study that is done in the Southwest, then you will now look for a study that is done in any part of Nigeria. If there's no study done in Nigeria, then you will look for a study done in West Africa. If there's no study done in West Africa, then you will look for a study done in any part of Africa. If there's no study done in any part of Africa, then you look for a study done internationally. If there is no study done anywhere in the world, then you are permitted to use 50% prevalence. That's by default. And don't jump and go and use 50% because your supervisors can go to the internet and search. And it's rare because most of the studies we do at the master's level and undergraduate level are not novel. So there's a good chance that you will find a study. Don't go and do one wishy-wishy thing. Just check online, sharp. Say, I didn't find anything. Let me use 50%. 50% will give you a sample size, a minimum sample size of 400 and something. And I'm sure you are not ready for that. So please find, you will find. If you don't find in Nigeria, which I doubt, then you will find in other African countries. It's when you don't find a prevalence anywhere, that's when you're allowed to use 50%. And be careful, because like if you have a supervisor like Professor Mojib, trust me, he knows how to search for these things. If he finds it, then it means that you will have to go back to the field because your sample size will be recalculated, and that's not good enough. Please do your homework well before you conclude. Are there sites we can validate study? There's no sites to validate. There are only sites where you can get validated tools, meaning these tools have already been validated by organizations. Like the tool I used for my noise-induced hearing loss was already validated by the American Audiology Society. But interestingly, because that tool was used in the US, I validated it in Nigeria as well. Yeah, that is standard. If you get a validated tool, for example, that tool was validated, like most WHO tools are not validated in one region. So you can use them anywhere. But there are some tools that are validated in only one place. Like the example I gave you was validated only in the US. But because I was supposed to use that tool in Nigeria, I had to validate it in Nigeria for me to be able to use it in Nigeria. Because if I don't do that, if I want to publish that work, the reviewers will still ask, how did you know that the questions that were asked to people in the US, the way they understood those questions in the US, do you think that's the way they understood the questions in Nigeria? And that's a good, valid question. So I had to validate it to ensure that the same questions they were asking them in the US, when I ask the people in Nigeria, the answers they are giving me is related to the question that I'm asking them. So that's the purpose of validation. You're getting what the tool is measuring. So you cannot validate online, but you can get validated tool online. And I've shown you the other methods you can use to validate your questionnaire. But there's no application for validation unless you want to do internal consistency validation, which I told you that you can use the Chromebase Alpha to do. Yeah. Okay, so I hope I'm not extending the session too much. Somebody is raising their hand up. Could you please unmute yourself and ask? That's Dr. Abiora something. Please unmute yourself and ask. Dr. Obiora, sorry about that. Dr. Obiora, yeah, Dr. Obiora. I didn't see the name well, sorry.
Yeah, okay,
you are
yes, you have attended to my question. Thank you.
The same, okay, all right. Okay. So can you please, someone is asking, can you please summarize what data validation entails? And do you just go to the WHO webpage to get their validation tool if you decide to use that? Yes. WHO tools are available for free. You can go to the website and get it. You don't need any permission. All right. So what you do is, if you have a project, if you have a study, for example, your study is prevalence of depression, just go to the internet and just type WHO validated tool for prevalence of depression. If the tool is there, to come out. Okay. But talking about the validation now, I don't think it's something that I can explain again now, because I had spent some minutes talking about it. So you would hear about it again when you listen to the recording. But you can get validation tools online. Sometimes they may not be WHO. Sometimes they may be UNICEF. Sometimes they may be other organizations. Like the example I gave, my own was from the American Audiology Society. They have a validated tool for measuring noise-induced hearing loss. So I didn't need to design a new tool. All I needed to do was validate their own tool in Nigeria. That's all. I didn't have to design a new tool. So that saves me time and headache. So that's the benefit of using validated tool. Most times, the only thing you can add in the validated tool is the social demographic characteristics, because sometimes they may use their own social demographic which may not align with yours. So you're allowed to use that, but every other thing can be theirs. And another thing I can add, sometimes you may want to adapt the tool. Sometimes you may want to change some things in the tool. It is allowed. But like I said, if you decide to add things to already existing validated tool, you will still have to revalidate that tool. Yes, you will still have to. So for example, now you found a tool that have 15 questions and you now want to add 5 to make it 20. Automatically, you will have to revalidate that tool. Okay, all right. I think it seems we have exhausted our time. Thank you very much, everyone that have asked the question. Let's continue to do the questions and answers in the forums. Yeah. So in the forums. Thank you very much for the sessions and for everyone that have attended. Thank you.
Thank you.